go. Okay, so this is, do you guys both have these? I think I gave this.
Which page are we on?
This is worksheet number 1 in the blood system. So we're just going to be talking about like the red blood cells and plasma. And blood consists of, well, red blood cells. You got it okay?
Yeah.
Got it?
Got it.
Okay. So blood consists of red blood cells, plasma proteins, and plasma. And plasma is just like the liquid blood. So that's kind of what we're going to be going over. So there's a little bit of a discussion. So what does blood do for the body?
Helps circulate nutrients.
Okay.
In the body.
Circulates nutrients.
Carries oxygen or carbon dioxide in and out of the
Yeah.
lungs and such.
Yep. Oxygen and carbon dioxide exchange. So gas exchange, gas transport.
Regulate pH.
Regulates pH. And electrolyte. It's up there.
I was trying to do it.
No, that's fine. No, that's okay. I mean, this is just stuff to talk about, like in case there's something that's not seen. Blood also defends the body against toxins and pathogens. That's more of your white blood cells. And the blood distributes heat and regulates temperature. So an example of this is like when you go running, your face gets really hot because those capillaries on the vessels towards your face dilate. But then when you're cold, what does your face look like? You look pale, right? Because your capillaries have dilated on the surface of your face, they have constricted, which means they've gotten smaller. And all the blood has rushed to your organs because it's trying to protect your organs, right? You can lose your nose, you can lose your finger, but you can't lose your heart, you can't lose your stomach. So that's kind of what blood does, and that's why it's important. So number 2, the statement blood is classified as connective tissue. This is true because a connective tissue connects things. So blood connects everything. Blood is, in the endocrine system, everywhere else. It is the primary, it's the most important. So formed elements are in the blood. This includes your red blood cells, white blood cells, and platelets. So what do red blood cells do? It's a little... Red blood cells transport gases. Yeah, no, gases. Nutrients just circulate.
Oh, okay.
Yeah, nothing transports nutrients. No, but you got it. Yeah, it transports oxygen. What about white blood cells? Immunity. Yeah, our immune and defense. And then platelets aid in clotting. And this is a little bit of a little fun fact. What vitamin also helps with clotting?
Hemoglobin. No.
Hemoglobin's a protein.
Oh, protein.
Vitamin K. So wait, if you ever have to learn about vitamins, vitamin K helps with clotting. So if that helps you. I don't know if you can see that there, but yeah, that's just a little fun fact. But yeah, so formed elements, if you see the word formed elements, you hear elements and you kind of freak out a little bit because like, what's an element? It's just asking for red blood cell, white blood cell, and platelets. The next statement, so 55% of blood is known as plasma, so that's the liquid, fluid, sticky portion of it that everything circulates in. The next statement, number...
What you just said. Plasma is the
liquid, sticky. Yeah, it's kind of like plasma. I don't know how else to say it.
Can I ask a question about that?
No.
So,
Go ahead.
when they put the thing through a
Centrifuge? Mm-hmm.
or whatever that's called,
Yeah.
the top part is the liquid,
Yeah.
and that's the blood cells.
Yeah.
And then the bottom is the plasma and the sticky stuff, or is that vice versa?
Actually, I don't know. I'm going to look it up really fast.
Okay.
So,
I guess I could have looked it up.
no, that's a good question. I'm pretty sure the formed elements go to the bottom, but let's... Okay, so here we go. So can you see that okay? Yeah. So plasma is at the top. Um, White blood cells are in platelets, then form the middle line, and red blood cells is the bottom. Good question.
No, that's in, like, if you get blood drawn, they put it through a centrifuge,
So
and
if you get,
it separates.
yeah, they take this,
Yeah.
yeah, no, they just take blood and they put it in this circular, this is a centrifuge, and basically you put it in and it spins your vial of blood around and it separates your blood. And that's how they measure like how much you have sometimes. So, yep. So that's what that is. She was just asking about that. Look at all these pictures of blood. Isn't that nice? Or like vampires. All right. So hemocytoblasts are found in the yellow bone marrow. This statement is false. Yellow bone marrow only contains fat. Hemocytoblasts are found in the red bone marrow. So when we break down hemocytoblasts, what does this tell us? How does breaking down this word help us?
Blast filled,
Mm-hmm.
hemo is blood, and cyto is, out. No,
Try again.
what?
Try again. Try again. It's a 4-letter word.
Hell, I don't know.
Cell.
Cell, yeah. Blood cell builder.
Yeah. So hemo means blood, cyto means cell, and blast means like to build or to create. Whatever. So this is kind of how red blood cells, so it's basically hemocytoblasts are like baby red blood cells. Red blood cells are like adults and they're mature. You know, they have their own professions, white blood cells. So if you look at this as a thing, hemocytoblasts are the babies of any cell, any white blood cell, platelet, red blood cell, or even your lymphocytes. And what are lymphocytes?
Lymph cells.
Lymph cells that help with, yeah.
B cells.
Yep, T cells and B cells, exactly.
I'm learning this for nursing too, so that's good.
Great, yes. So like if you think about in terms, hemocytoblasts are the babies, these are like the adults and these are their professions. Yeah, they have jobs now. So your hemocytoblast can either, so it'll split. It'll start as a hematopoietic stem cell? Sure, why not? And it'll either turn into another stem cell, and a stem cell is just a cell that can turn into any other cells. So it's like super cell. Or it'll turn to a specialized cell. If it turns into a specialized cell, this specialized cell can then either take the career track of a myeloid stem cell or a lymphoid stem cell. So lymphoid stem cells turn into lymphocytes, which, as you said, was the T's and the B cells. And then the myeloid stem cells are either going to be red blood cells, platelets, or white blood cells. So just if you see hematocytoblast, just know that they turn into every cell in the body.
So that's just like the baby, like beginner.
Yeah, baby beginner cell, yeah.
Okay. So then they both turn into either a specialized cell or a stem cell, which is
Mhm.
both specialized. No,
Yeah.
stem cell's not.
Stem cells not specialized.
Okay, got it.
Yep. So, any questions on that? So that's just kind of where red blood, and this happens in the red bone marrow. So number 6, the statement is asking, red blood cells have a mitochondria and a nuclei. This is false. Red blood cells do not have a mitochondria and they do not have a nuclei. Yes, they do not divide. I don't know if they conquer though. Okay, that's okay. And so now this next one, what is false about erythropoietin? It is a hormone. Where is it produced?
Oh, in the kidneys. Or
What were you going to say?
the antigen part.
No, it is actually in the kidneys. Sorry. But yeah, erythropoietin, your kidneys will produce erythropoietin. Erythropoietin hormone will then go to your bone marrow and it will tell your bone marrow, hey, produce more red blood cells. So that's what'll happen. Yeah, it's not stimulated by that. It's stimulated by low amounts of red blood cells, and so like anemia. Yeah, yeah. So in order to make, so let's review the true answers. It is a hormone. It is released by the kidneys, sometimes, sometimes by the liver too. It stimulates red blood cell formation, so it causes red blood cells to form. And what causes the secretion of erythropoietin from the kidneys is when you have too little red blood cells in your body. So that's that. Vitamin B12, so number 8, vitamin B12 is also known as folic acid. No, you're fine. And it is required for hemoglobin synthesis. This is false. Iron is actually what is needed for hemoglobin synthesis. And what is the sign for iron? It's tricky. It's not. It's. There we go. So iron is really important for hemoglobin synthesis. But yeah, go on. No. Yeah. So to make that true. Yeah, and you also take out folic acid. Vitamin B12 is actually known as folic acid, but hemoglobin synthesis is iron. So B12, which is folic acid, is actually needed for DNA synthesis and the growth and division of cells. So that's why B12 is important. But you have to know about folic acid, also known as B12, and you got to know about iron, so I kind of threw that in there. So now we're going to be talking about anemias. And since we're talking about B12, we're going to be talking about pernicious anemia with this P1 right here. This is actually caused by a B12 deficiency, and it is due to the deficiency of intrinsic factor. And I know you guys haven't had the digestive system yet, but intrinsic factor is something that is produced by your stomach. So if you don't have intrinsic factor, you don't absorb B12, and therefore you have anemia because you don't have B12 to let your blood cells produce and divide. So that's with that. So a lot of people who have stomach conditions, or maybe they got part of their stomach removed, they don't produce enough intrinsic factor, and so they have anemia because of that. So that's just, extra fact. But just know pernicious anemia and B12. Those two go hand in hand. Another thing. Overall, anemia means loss of blood. Yeah. So in Latin, you're fine. In Latin, anemia So anemia means without blood. And what we were just reviewing was over pernicious anemia is a type of anemia that is caused by B12 deficiency. This is due to the loss or the deficiency of intrinsic factor. And intrinsic factor is something produced by your stomach. So if you don't produce intrinsic factor, you don't absorb B12. And B12 is really important for red blood cell growth and division and development. Well, not division, but because they don't divide. But just it's just important. So even on a nursing exam, if you see something about intrinsic factor, B12, or pernicious anemia, those go all together. Yeah. Oh.
A lot of those things
Makes sense?
Yes.
Yeah. Well, this is just review then for you. Another anemia, because anemia means without blood, is hemorrhagic anemia. And this has to do with if you sever your limb or something. Hemorrhagic anemia is caused by a hemorrhage, so you're bleeding a lot. And because of this, you also lose a lot of your red blood cells. Aplastic anemia. This is caused by, aplastic means without any cells. So you'll have a low white blood cell, low red blood cell. All of your formed elements will be low. And this is caused by destruction of the red bone marrow. So the red bone marrow is destroyed that process that we did earlier, the mapping, none of that would have happened. So aplastic anemia is completely, everything else is away. And this can be the result of cancer or toxic drugs. Another one is iron deficiency anemia. It's caused by a lack of iron. You know, imagine that. That's not a trick question. And this actually leads to hemoglobin deficiency because hemoglobin needs iron. So there's that. Iron deficiency anemia is also known as hypochromic. So hypo in Latin hypo means a little bit, and chromic means like color. So hypochromic means, you know, because people with iron deficiency, they have like blue fingernails, and because they don't have enough hemoglobin, and what makes hemoglobin red is oxygen. So if you don't have hemoglobin, your red blood cells can't obtain oxygen, and therefore you tend to look a little more blue, a little more pale than you usually would. So that's where iron deficiency comes from, and that loss of color. Lastly, we have hemolytic anemia. And this can be due to bacterial infection, but also malaria. I did not put that in the worksheet, but I should have. Hemolytic anemia, hemo meaning blood, and lytic meaning like to split. So lytic, split, slicing, splicing. So hemo means blood, lytic means to like slice or to cut. This just happens when the malaria virus or a bacterial infection causes your red blood cells to rupture. This is also known as hemolysis, so blood splitting, which isn't fun. So any questions on those? No? Okay. So this one I stole from an instructor's PowerPoint. And this is like, so the first one was how red blood cells were created. Now this is going into how red blood cells are destroyed. So damaged red blood cells are phagocytized, and phagocytized means eat. They are consumed by macrophages in the liver or spleen. And macrophages, I think of those like Pac-Man. So in the liver or spleen, they kind of eat like bad things, which is great because we don't want those bad things in our body. So damaged macrophages, then so they get phagocytized, and then there are two parts of the red blood cell. There's one part known as hemoglobin, which is the protein. Hemoglobin either turns into globulin, which is a plasma protein in the blood, which is very important. You'll learn more about plasma proteins as we get into the urinary system, but there are three main ones. There's globulin, which is up here, fibrinogen, and what's the other one? It starts with an A, albumin. Very important for like fluid regulation and everything. You don't need to know about that now. But if you ever get a question about, you know, what do damaged red blood cells turn into? Well, damaged red blood cells, the hemoglobin portion either turns into globulin. It then also turns into heme, which is the iron portion. Iron is then, it goes to the red bone marrow and either makes more hemoglobin, so it's recycled, or it goes to the liver and it's stored there as ferritin. So that's why people who eat liver tend to have, it has a lot of iron in it. Liver is actually very disgusting because it also filters everything in the body. So while you're getting that iron, you're also getting all the waste, whatever creature ate. Yeah, liver's nasty. For sure. So heme, so the iron portion of heme will either go to liver or it'll go to the bone marrow. The other portion of heme will turn to biliverdin, and what does this remind you of? Biliverdin, bile, right? So some of biliverdin converts into bilirubin. Either way, it doesn't matter. Both biliverdin and bilirubin have the destiny of turning into a bile pigment. Imagine interviewing a red blood cell. The only purpose in your life is to be a bile pigment. Yeah, that's great. And then the rest of the worn out debris of the red blood cell, because the only useful portion is hemoglobin. That's why it gets taken down into all these bile pigments or new hemoglobin, or stored in liver as ferritin, or turned into globulin. But the other ones get digested, recycled, excreted as waste, all that wonderful things. So, any questions? Is it kind of straightforward at least? Okay, good, because I stole this one. So this statement is, which of the three below does not destroy red blood cells? The answer to it is red bone marrow. Red bone marrow creates red blood cells. The spleen and the liver are the two organs that destroy red blood cells. The next statement, albumin, globulin, and fibrinogen are all known as plasma proteins. So your blood is made up of plasma, red blood cells, nutrients, gases, all this jazz, and also plasma proteins. And plasma proteins are really important for fluid regulation. Oh, and there are nutrients there. So now we're going to go over some plasma nutrients, select all that apply. This includes simple sugars, such as, what's a simple sugar? Glucose, yes. Amino acids, which are just debris of protein, right? So if a protein gets broken down, it turns into amino acids. Nucleotides, which is segments of DNA. Lipoproteins, which are proteins and fats combined. So yeah, fatty proteins, there you go. And then also lipids. So those are some nutrients. And then there are also three types of lipids. That's a little bit of a bonus thing at the bottom here. There are fats and triglycerides, phospholipids, and cholesterol. So I know we're not quite in the digestive system. Yeah, I won't go into phospholipids. But phospholipids basically form the membrane of every cell. So remember the lipid bilayer, the phospholipid bilayer, that's what a phospholipid is. But yeah, plasma nutrients. All this good stuff. And then you will have access to all this stuff too. Oh, here's something else. Oxygen and carbon dioxide are blood gases. Lipoproteins, chylomicrons, VLDLs, LDLs, and HDLs, or LDL and HDL. So I think chylomicrons have something to do with bile. I don't quite remember off the top of my head. But HDL, LDL, and VLDL is basically forms of cholesterol. HDL you want a lot of, LDL you want a little bit of, and VLDLs you want very little of. You don't want any very low density lipoproteins. So, and this is also something I stole too because I didn't really want to use it. But these are more descriptions, and you will get this. You'll get this when I send it to you, the answer sheet. So we're going to go into this statement, and this is asking about non-protein nitrogenous substances. It's asking if it's protein, and if it's not, it's false because, well, if you look at the word, it's non-protein nitrogenous substances. And these are molecules that contain nitrogen but are not proteins. So these, if I don't know.
I was just asking.
No, I think.
Know if I missed something.
No, I don't. I'm not sure.
Different types of things with.
Yeah, it's just nitrogen that, I think it's, cause some of these are from. I think what I was thinking when I made this is I was talking about urea, and urea comes from when protein breaks down.
Okay.
So I think I just was like, hey, let's put a fun question in there. Yeah, are they proteins? No, it's good. Don't apologize. So these are just some non-protein nitrogenous substances. So these are waste products, basically. Urea, which goes to urine, uric acid, which also goes to urine, and amino acids, which is the product of protein digestion. So these are not proteins, but they are like the leftovers. So once proteins break down, this is what they are. Another one is creatinine, and this is production from creatine metabolism, BUN, blood urea nitrogen, which is very important for kidney health. And if you have too high of a BUN, the kidneys aren't filtering or excreting. It's just, if you see any of these words, just know that they're waste. That's what's most important. As we go along in more of the chapters, you'll see why these are mainly the urinary chapter. So number 14 is saying, it's a fill in the blank. So urea is a product of protein catabolism, and uric acid aids in nucleic acid catabolism. Catabolism, not cannibalism, catabolism is the breakdown of either proteins or nucleic acids. So just, I don't know, it's circulating in your blood, keep it in mind. It's in your plasma. So now we're going to move on to electrolytes. So electrolytes in the blood plasma, the most abundant would be sodium and chloride. So when you think of sodium and chloride, what do you think of? Table salt. Yeah. And actually what's really interesting is sodium is, I think it's like a poisonous, it's a liquid metal, and chloride is like a poisonous gas, but if you combine them together, then we have salt for some reason. Yeah, pretty neat. Yeah, no kidding. I mean, who came up with that, right? So that concludes red blood cells. Now we're going to go into white blood cells.